Hi everybody, in this video we're going to really get into graphing linear equations here in two variables, and there are a few different strategies that you can use to graph linear equations. So in this first part of graphing, we're going to talk about the plotting points method. Okay. So first of all, a linear equation in two variables is an equation that can be written in the form ax plus by equals c, where a, b, and c are real numbers, and a and b are not both zero. So meaning like both a and b can't be zero. You have to have at least one variable there represented, right? You can't get rid of both variables. So here are some examples. Something like 2x plus 3y equals 4. You could also have something like 4x is equal to 6. Now, the reason this actually works is because you could write this as 4x plus 0y equals 6, right? So the b value here is a 0, so it still is in the same form. You could have something like y equals 5, again, because really it would be 0x plus y equals 5. So it does still fit that same form of having two variables. Now, you can also have things like fractions and decimals and much more complicated examples too. So this would sort of be like the simplified form of a linear equation in two variables, but it doesn't mean that you can't have parentheses or fractions or decimals or other things like that. I do want you to notice, though, some key things here for the idea of linear is that there are no squares or cubes, etc., on the variables. So even though we can have fractions and decimals and things like that, we're not going to see any exponents here besides 1. So we're not going to see squares or cubes or things like that. They do exist. There are equations like that, but we're not going to get to that in this class, or at least for graphing at this point in time. There will be no dividing by a variable. So for instance, like a 1 over x idea, again, we have things like that, but we're not going to graph them in this class. We're going to graph them in later classes. And there will be no multiplying x times y. So like you're not going to see x times y like that. Again, that stuff exists, but we're not going to graph it in this class. Not that we're not going to multiply or do things like this. We've seen stuff like this before for expressions, but for graphing purposes, we're not going to touch on that. So if something is linear, they are some of the more simple graphs, right? We're not going to do anything too crazy to those variables, basically. And the big thing that you're going to see here is that the graph is a straight line. That is why they're called linear. Linear has the word line in it. So all your graphs in this section are going to be straight lines. So we're going to be focusing on graphing this specific kind of equation. But of course, many other kinds of equations exist. So I don't want you to think that there are not other kinds. There are plenty of other different examples, but we're going to focus in this class on the linear, which are the most simple ones. Okay. So in this video, I'm going to use the most basic of ways that you can graph a linear equation. And it's typically called like plotting point strategy or graphing by plotting points, something like that. Is typically what it's called, or kind of what you hear. So what are we going to do there? So the first thing you're going to do is you're going to choose one number to plug in or one variable. Okay, so I'm going to do an example in a different color underneath it. So for example, let's say I'm going to choose something like x equals 2. Okay. And let's pretend like we're doing an example along the way. So maybe I'm trying to graph 3x plus y equals 6. Okay. So the first thing you do is you choose one number to plug in for one variable. And you really do get to choose. You literally can pick any number you want in the world. So if I wanted to pick 1 million, I could pick 1 million. If I want to pick 7.412, I could pick 7.412. But I want to make my life easy. So I'm going to choose 2, something nice and simple. And then what you're going to do is you're going to plug that value into the equation and solve for the missing variable. Okay, so let's do it. So I'm choosing x equals 2. So I'm going to go up to my equation here. And I chose x equals 2. So I'm going to replace it in the equation. And then I'm going to solve. So in this case, I'm solving for y. So 3 times 2 is 6. Now I do want to get this by itself. So I'm going to subtract 6 from both sides. And I get y is equal to 0. And now you're going to put these values together to create a point, which is also a solution. So do remember that your point should be x comma y. So for this particular example, my x value was 2 and my y value was 0. So now I have my first point. And then what you're going to do is you're going to repeat this process at least one more time. Okay? So what happens is you always need at least 2 points to graph a line. Okay? So when you're graphing lines in particular, you need at least 2 points in general to graph a line, but a third point is always good to help you check. So I do recommend trying to find at least 3 points when you're graphing. When you get to more complicated graphs like curves or circles, we often need more than just 2 or 3 points. So again, this is specifically for lines in general. We typically like at least 2 points to graph. But that third point is really nice because it will help you just check your work. Now, I will say that when you're graphing in a program like MyMathLab or online, they may not let you insert that third point. They may just require you to do 2 points, and which is fine. But so then you can visually check your third point instead of graphing it as well. And then what you're going to do is draw a line. Through your points, and you're done. So that's how you're going to graph. Now I'm going to bring this example to the next page and continue it because we only have 1 point. I don't have enough points yet. So let's go to the next page. I'm going to rewrite this example so we have it. So from the first page, we already found our first point, which was 2, 0. So now I do need to repeat the process. And I will also show you another trick that I do. I typically like to make a table as I'm going through. It just helps me to stay organized. So in the first example, I chose x as 2, and then I found the value of 0. So now I'm going to go ahead and do another point. This time I'm going to choose the value of x equals, I don't know, how about we do -1. So I'm going to go to my equation here. I'm going to replace x with -1. And I'm going to go ahead and I'm going to solve. 3 times -1 is -3 plus y equals 6. Go back to your regular solving rules here. I'm going to add 3 to both sides, and I have y equals 9. So here I chose -1, and my y value was 9. I end up with the point -1, 9. Again, don't forget, you're still in that form xy. Now, technically 2 points are enough, but I usually do like to find a third point. I do find it best to have at least 3 points. So this time I'm going to pick a y value. You can pick an x or you can pick a y. Let's see, I'm going to pick y is equal to, how about 1 here? So I have 3x plus 1, 6. So I'm replacing that y value, right? I have to solve, so I'm going to subtract 1 from both sides. 3x is equal to 5. I'm going to divide by 3. I get x is equal to 5/3. Now you may want to change this to a mixed number just so you have a better idea what it is. 3 goes into 5 one time, and you're going to see a remainder of 2. So you have 1 2/3. So here I chose y as 1, and then my x value was 1 2/3. Now, when you have fractions or decimals as an answer, they're kind of hard to graph, right? Because you have to estimate. So what I'm going to do here is I'm going to use my 2 other points as my main points to plot, and then I'll use my third one just as a check to make sure everything looks good. So I'm going to go ahead and just draw in. Let's see, my values felt pretty high to 9, so I'm going to just kind of put my x-axis a little low here so I have enough room. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then obviously I have my negatives going down. And then I have 1 and 2, 3, 4, 5, 6, and so on. And you can kind of notice that I'm just filling in a couple points here. I don't really need to fill in every single value once I get comfortable graphing, but I need enough to know my scaling. And I'm going to graph my points. So I'm going to start with 2, 0. So my x value is 2, my y value is 0, so I'm going to stay right on the axis. And then I have -1 for the x value, and then +9. So what I'm going to do at this point is I'm going to take out a ruler or a straight edge. You really want to try to get in the habit of using something straight to draw your points if you're doing it by hand. Now I know it's not going to be perfect, but hopefully it'll look pretty good. And then the third point I'm going to use to check. Now, if that third point is totally nowhere near my line, then I know I did something wrong, right? Because these should all be on the same straight line. Okay, so that's what that third point is really for, is to check. Because if your third point is not on that line, then you know something is wrong somewhere. Doesn't, you don't know where it's wrong, but you know it's wrong. So my third point is 1 2/3, comma 1. So 1 2/3 is about right here, and then 1 is about right here. So it does look pretty close, right? Now, I'm going to give myself a little bit of leeway because I did it by hand. So, my line is be a little bit better tilted here to go better through that point. But it looks pretty good, right? So I'm going to go with that. I look good here. If my point was something like 1 2/3, comma 5, and my point should have been up here, then I know that I did something really wrong, right? So that third point is really your check, just to make sure everything is on a straight line. And that's it. There's your graph. So the interesting thing too with this graph is that that line actually has infinitely many points on it, and it continues forever in both directions. So you have infinitely many points, which means you also have infinitely many solutions. So it's kind of fun to graph with a partner because you guys could both pick totally different points to plug in and still get the same visual, which is, I think, really interesting. All right, let's do another example. So y equals 1/3 x plus 1. So I'm going to set up myself a little table to start, but I am going to find at least 3 points here. So let's do my first point. Now, this one's a little bit harder because I have a fraction. It's like, ooh, fractions, right? I thought we were done with fractions, but we're not. We have fractions here. So I'm just going to leave the fraction. I'm not going to cancel it out. It's just going to get kind of messy. So I'm going to leave it. But I'm going to try to think of values that I can plug in to cancel the fraction. So for this example, I'm not going to pick y values so much because that's not going to cancel my fraction. I'm going to try to pick x values that would cancel out a 1/3. So the first value that I can think of that would cancel that 1/3 and make my life pretty easy is 0. So I'm going to go ahead and I'm going to replace that x with 0. And hopefully you guys know that anything times 0 is just 0, right? So this becomes 0 plus 1, which is just 1. So my first point is going to be 0, comma 1. All right. Now, again, I could pick y values if I want. So I can do that. I just kind of want to try to cancel out that fraction personally and get rid of it. So I'm going to try to think of an x value that would cancel with a denominator of 3. And if I choose x equals positive 3, then I should be able to get this to cancel, right? If I choose the same thing as my denominator, because what's going to happen is that 3 over 3 is going to cancel out. Now, if you're not sure, you can always multiply straight across. And what happens is you get 3 over 3 plus 1. Well, 3 over 3 is just 1, and 1 plus 1 is 2. So I get my next point, 3, comma 2. I'm going to pick another one. I'm going to choose x equals negative 6 this time. Again, I'm just trying to think of values that when I divide by a 3 are going to cancel out. And I know 6 divided by 3 is 2, so I'm going to choose that. So I end up with negative 6 over 3 plus 1. Well, negative 6 over 3 is negative 2, plus 1 is negative 1. So I have 6, 1. And that should be plenty. So I have lots of points here. Now, I will tell you that let's say you pick a value for x and you can't get rid of the fraction. It's not the end of the world. You can just estimate it if you're doing it by hand. I will say, though, that my math lab and some of the graphing tools don't always like fractions and decimals. So if you're getting a fraction in your point and you're not able to graph it on technology, you're just going to have to pick another value until you get something that is not a fraction. So if that happens to you during an assignment and you're like, but I can't graph it on my technology that I'm using, then just keep picking other values to plug in until you get one that works. So I have 1, 2, 3, 4, 5, 6. -1, -2, 3, 4, 5, 6. 1, 2, 3, 4, 5. -1, -2, -3, -4, -5. So just putting a few points in there to show my scaling. And I'm going to start graphing. So I have 0, 1. I have 3, 2. And again, that should be sufficient, but I'm going to graph that third point here just to double check. So I have -6, -1 is right here. If I take out a straight edge, it could be a ruler or a side of a notebook, piece of paper, doesn't matter as long as it's straight. You just want to see if you can get right through the centers of the points. And draw your line. Now all 3 points clearly are all on that same line, so I know I did a good job. And this should be good. So there's my graph. I'm going to do one more example with you guys just to kind of just do a little bit more practice. So I'm going to graph y equals -4x here. And I'm just going to pick some values. So I'm going to start with x equals 0 and plug that in. Zeros tend to be pretty easy most of the time, so I tend to like to plug in zeros. So I'm going to replace the x value with 0 here. And when I solve for y, -4 times 0 is just 0. So I get my first point of 0, 0. I'm going to plug in x equals 1. So I've replaced the x with 1 now. -4 times 1 is -4. So when I had x is 1, my y value is -4. So again, that's just another way. I just like to use a table to stay organized, but it's just a point. All right, maybe I want to pick a y value here. Maybe I want to pick y equals 6. So I would have 6 equals -4x. I'm going to divide by -4 on both sides. All right, so I have a positive divided by negative, so it's going to stay negative. And then 6/4 I can reduce that by 2. So if I divide both of those by 2, I get 3/2. And again, I'm going to change this to a mixed number, so I get -1.5. All right, so that one's not too bad. It's kind of a messy one, though. So maybe I pick another value to plug into. Oops, sorry, this was 3. And we'll do a fourth one. I'm going to plug in x equals, how about -1? -4 times -1 is positive 4. So here was an example where I picked a value to plug in. I got a fraction answer. Now, -1.5 is not too bad, but I don't really want to work with fractions today. So I'm just going to pick another value to plug back in. The x's seem to be working pretty well for me. So I went back and plugged in an x value instead. And then I'm going to go ahead and graph. You do want to make sure you have at least 3, again, at least 2 technically, but a third one is best. So at least 3 distinct points. Sometimes when we're clicking values, if you get the same point twice, like maybe I wasn't paying attention to how I was choosing values, I ended up with the same point twice, just make sure you pick again. You want to have at least 2, but particularly 3 different points, okay? Or if you get something you don't like, just pick again and keep trying. So let's see, I have 1, 2, 3, 4, 5, 6, -1, 2, 3, 4, 5, -6, 1, 2, 3, 4, 5, here, 1, 2, 4, -5. All right, so my first point is 0, 0 right at the origin. Then I have +1 for the x value and -4, so right down here. If you want to fill in all those numbers, please do. I'm just kind of saving some writing because it gets a little bit squishy here, but this would be 1, 2, 3, 4, 5, and so on. And then I have -1, +4. So here's -1, and here is +4. So I'm going to use those 3 points instead. I can see that they're all on the same line. Again, I really only need 2 of these to graph, but that third one just kind of gives me a nice little check to make sure I really do have a line. The fourth one I could also use to check. So -1.5 would be like here. And then 6 would be about right here. So that actually does look like it's on point to match as well. So 2 points is the minimum to graph. But extra points are always good just to check that you haven't made mistakes. So if all those points are on the same line, then you're probably good. You probably haven't made any mistakes.